This is Woodman here with another channeled message. If you've ever watched the Matrix movies by the Wachowskis, you would get a lot of ideas about how the world works. One being that many scientists are now in belief that we may actually be living in a simulated reality, a reality that is beyond what we see every day. But a less explored aspect of the Matrix movies is whether human beings could be and are being used as flash batteries. The simple answer this time is no. They just aren't, as far as we can tell, and thermodynamics helps to inform us why there are many valid reasons why we're just not good as batteries. But I did want to read you an article from Wired UK magazine in 2023. While the human body cannot really generate the high amounts of energy needed to power certain devices, if the devices themselves are planted inside the human body, then we might be able to generate just enough energy to power some of these implants. The article here is called The Battery That Never Gets Flat, and I'd like to read it to you. Humans are complex machines with moving parts that bend, swish, stretch, flow, quiver, and beat. Scientists are now plugging into these energy sources to solve a common problem afflicting sensors, wearables, and implanted medical devices the dreaded flat battery. Devices that are self powered by design could be the solution, and researchers have discovered that the human body itself can be a handy power source just in time to power the exploding market in wearables. Electroceuticals are starting to challenge pharmaceuticals in medicine, so more people will depend on devices such as implanted electrostimulators and pacemakers in order to stay healthy. Scientists have been working on body powered devices since the early 2000s. And until now, the tech has been too energy hungry for the minute amounts of electricity that can be harvested from humans. However, after 2 decades of advances, today's devices consume ultra low amounts of energy, throwing open the gate to a myriad of ideas and prototypes that could draw power from the people. A cellular powerhouse. Your cells are basically batteries, biochemical ones that convert sugary fuel into energy. German startup Keltro is tapping into this living power source by utilizing arrays of microneedles to harvest tiny amounts of electricity from hundreds of thousands of cells. Celtro's first product will be a tiny autonomous pacemaker. A muscular contraction like the heart starts at one point and then propagates through the whole heart muscle, says CEO and co founder Jared Teep. Our idea was to harvest energy at multiple points to use this avalanche effect. As well as harvesting energy, the multifunctional microneedles will plug into the cardiac tissue to help monitor the heart and deliver a helping electrical boost to restore pacing if needed. In 2021, Keltro raised seed funding for lab based proof of concept studies. Paper fuel cells. French startup BEFC is building biobatteries with green credentials. Its fuel cell uses layers of carbon, cellulose, and glucose, plus a sprinkling of proprietary enzymes. Adding a drop of fluid, say blood or urine, could set up the necessary reaction that generates electricity. The paper patches could cover single use diagnostic devices and continuous monitoring sensors, such as glucose monitoring kits for people with diabetes. After use, the cells can even be composted, unlike other miniature batteries that are eventually binned or incinerated. BFC is currently raising Series A funding and expects to hit the market in 2024 with its first products. My Quivering Heart. Paris based Cardac is designing a pacemaker that's powered by the heart itself. Its leadless pacemaker is packed into a capsule containing a piezoelectric energy harvester, a pendulum that swings through heartbeats. the blood flow and vibrations. The oscillations are converted into electricity and stored until the device senses that the heart needs a jolt to reset the rhythm. The startup recently raised 17 million euros, which is about $18.3 million in Series A financing to continue preclinical testing and move towards human trials. Interior illumination. Solar panels are becoming a common household sight, and they could soon be lighting up medtech too. Researchers from Monash University in Melbourne, Australia have found that a solar panel placed under the skin still yields up to 10% as much as electricity as one in direct sunlight, enough to power an ultra-low consumption sensor. A couple of hours in the sun can run an implantable temperature sensor for 24 hours, and the researchers say the best place for it is between the neck and the shoulder. The hydroelectric heart. Mini turbines could harness blood flow and turn it into electricity, according to researchers at the University of Bern in Switzerland. They've designed a torpedo-shaped turbine that could be implanted into a blood vessel in the heart, generating electricity from the blood flow, much like a hydroelectric power station. A big challenge, as yet unsolved, is how to avoid blood clots forming on the blades of the turbine. But in lab simulators, the turbines generated enough energy to power commercially available leadless pacemakers. Sorry. Piezo patches. Italian startup Piezo Skin says it has developed an ultra-thin piezoelectric skin patch that can simultaneously measure movements and draw power from them. In one study, it used the patch to monitor neck movements in people with dysphagia or difficulty swallowing. But the firm's biocompatible film could also harvest power from other body movements and vibrations for sensors and wearables. Feeling the heat. Humans radiate around 100 watts a day in thermal energy. And according to Swiss startup Mithras, harnessing this heat could power wearable biosensors and even implanted devices. Its thermoelectric generators, known as TEGs, create electricity by exploiting the temperature difference between the body and the outside environment. Mithras estimates that with a 5 degrees Celsius difference, a 12 square centimeter TEG skin patch could completely power a cochlear implant. This article was originally published in the January-February 2023 issue of Wired UK magazine. I hope you enjoyed this article. If you're new here, welcome aboard. This is a safe space. If you're returning, thank you so much for your support. You make this channel possible. Welcome back. Also, please like, share, and subscribe. And I would like to leave you with the blessings of the Most High God at this time. For the most part, may the Lord God have a wonderful effect in your life, blessing you with abundance and showing you the way to the path of the life you feel you are meant to lead. Never give up, never give in. Woodman signing off. Have a wonderful and blessed day. Take care.